Hello everyone, so today we will be solving the problem sliding window maximum. So this is a very standard coding problem for topic sliding window. So I hope if you would have come to this video you would have read this question very well. Now I will be explaining you the summary of this question. So basically suppose we have been given this array and k is equals to 3. So what we actually need to do is we need to take k uh, k size window and we need to find out the maximum of that window and put it into my answer vector and then finally return that vector. Like if I take this example, my k is equals to 3, so I will be taking 1 2 and then 3, right? So 1 2 and 3, so the maximum value of 1 2 and 1 minus 3 and minus 1 is 1 3 and minus 1 is 3, and then I will be taking the next window as 3 minus 1 and 3 and the value will be 3, and in this window the maximum value is 5, so the answer is 5, and again in this window maximum is 5, so answer is 5, again in this window maximum is 6, so answer is 6. In this similar fashion, this is what the question is asking from us. So whenever this question comes up in an interview, the very first solution that you should give to the interviewer is what you are able to think at that point of time. You are never supposed to give the most optimal answer or the most optimal approach in the very first go. So you will be giving the brute force approach. So let's think the brute force approach for this problem. Like if we have been given this problem, let's look at a constraint. What are the constraint of this problem? The constraint is n and k. I mean, so constraint is 10 to the power 5, so we cannot give a solution with no of n square time complexity because that will lead to time limit exceeded. So we need to think something better. Now what we will first we will be discussing the brute force approach. The brute force approach is we will be starting from each index and then traveling to k index and finding in that specific window the value of the maximum value. Like suppose I will be starting from this 1 and then going till here and then finding out the maximum value 3, and then corresponding to this window I will be storing the answer 3. Now I will be at I is equals to 1. Now from I is equals to 1 2 I will go to, this is 2, this is 3, so from I is equals to 1 I will go to I plus k minus 1. Then I will be storing the maximum of that window and putting it into the answer vector. But interviewer will not be happy with this approach, although this approach is using time complex since this algorithm is using a time complexity of O of n square and space complexity of O of n, and the time limit exceeded will be a issue with this code. So we need to think something we need to think something in another fashion. uh, now I'll use the board for explaining what is actually being done over here. We will be using a queue data structure. Now all of a sudden you might be thinking how I would have thought queue. In the very first go I was not able to solve this problem. I was only able to be very honest, I was only able to solve the brute force approach, but after reading some articles and after reading some articles I was able to understand the how why why you are using this specific data structure DQ specifically in this problem. So what there is one speciality of DQ. uh, I hope you would be knowing what DQ is. So DQ is something in which you can push from front as well as push from back, as well as pop out from back as well from front as well as pop out from the back. So in this problem what we need to do is we will be taking a DQ data structure. This is the DQ data structure, and in this DQ data structure what we will be doing is we will be pushing the indexes. These will be pushing the indexes. Note, we will not be pushing nums of I, we will simply push I. Why so? I will make you understand after a few minutes. So suppose now I will be starting the iteration from I is equals to 0 to I is equals to n minus 1, where n is the size of the array. So this is the for loop that we are running. Now whenever I encounter any index I will simply push it. Like suppose I will be at 1, so I will push 0, then I will be at 3, I will push. So whenever I encounter something that is now I will be talking about how we are actually gonna deal the indexes in the DQ. So whenever you find anything that is present in the DQ that is out of range, that is actually out of range of the current window. What I mean is that if you are at I is equals to 4 and my k is equals to 2. What will be my range? I am at 4 and the previous indexes will be 2, 3, 4, 1, 0. So what will be my range? My range will be just this much. So in case my front element of the dq, this element of dq is equals to I minus k, or anything less than I minus k, I will simply pop the elements from the front of the dq. Can you please try to understand what actually I am saying is why I am popping out from the front? I'll be again explaining it. See, you are using this dq and you are pushing the elements over here. Suppose you are pushing these elements over here. Now what was the first element to be pushed in the dq, because that will be having the maximum probability that it might lie out of the range of the current sub window. So suppose since you have pushed this element at the very beginning, since you have pushed this element at the very beginning, this will be having the highest probability to lie outside the current window size. Yes, so we will be popping the element from the front. We will be popping the element from the front. Why? We will be popping the element from front because it will be having the highest probability to lie outside the current window range. So what we will check? We will check if this will be lying outside the window range. If lying outside window range, I will simply pop front the element, right? Simply pop front the element. Sorry, system is hanging a bit. Yeah. So now what I hope till now everything is clear. Now one more thing that we need to pop out. Suppose I will be explaining you with an example. Suppose I have few elements in my dq. These are the elements or the indexes that I have in my dq. Now if I encounter anything that is actually greater than these indexes, so suppose I encountered anything, a number that is greater than the values present at the given indexes in the dq. So do I actually need to keep these elements? Do I actually need to keep these elements? Think of it. If I have found anything greater than the previous indexes, do I actually need to keep? No, I am not supposed to keep those elements in the dq. So what I will do is I will simply pop these elements back, pop out these elements from the back of the dq. So I will be explaining it with an example. Suppose I am having 0, 1, 2, 3. Now I am standing at 4. Now if I check that if my nums of 4 is actually greater than these all suppose is greater than 3 and is greater than 4, what I actually need to do is I will simply pop this element out. I will simply pop these two elements out of the queue. Why so? Because C, which has more probability to lie in the next sliding windows. 4 is having more probability to lie in the next sliding windows rather than 2 and 3, because 2 and 3 are previous indexes. So I can simply very safely pop the elements out from the back of the dq. So so again we will be doing a pop operation from the back of the dq. So now after doing this pop front operation and pop back operation, we will simply push the current index in the back of the dq. Push back I, right? And in case my I is greater than equals to k minus 1, in case what this line actually means, that if I am at k minus 1, if my I is greater than equals to k minus 1, it means that my first window is over and we are into next consecutive windows. So from there we will be storing the indexes of dq, nums of dq dot front. I hope this code was this explanation was clear to you. If not, I will be explaining you currently the pseudo code, and please try to understand from the pseudo code whatever I have just taught you in the past few minutes, and try to relate those points and stuff using the code that I am going to write right now, pseudo code that I am going to write right now, and finally we will move on to the actual coding part. See, we will be taking a DQ data structure, right? Why DQ data structure? You might be very well versed with this question right now, because in DQ data structure we can pop the elements from front also and from back also, and in this problem we need to pop out pop up from two different places. I mean from the front because they lie outside the range, and from back because they lie because they are actually smaller than the current number. So what I need to do is I simply need to write the pseudocode. So pseudocode will be for the pseudocode will be for loop. There will be a for loop and then ending, and then there will be a while loop. Why while loop? This while loop, see, at the very beginning I told that we will be popping out elements from the front in case they lie outside the range of the current sliding window. So what we will do is, in case my dq dot front is less than equals to I minus k. So what does this mean? This means that the dq dot front element front pop, uh, I will be popping the element from the front because it is lying outside the, because it is lying outside the current window. And again now we will be popping from the back. So nums of dq dot back, if in case this element is smaller than nums of I, what I will do, I will simply pop back, right? And after doing these two operations, what I will do, I will simply push the current index, because I need to push the current index, right? And I had not done it till now, so I will push the current index dq dot push back I. And after doing all this, if in case suppose this was the array and my k is equals to 2, so in case my this is my I is equals to at this position, I will be having at the first window, and my calculations will be perfectly done in the dq data structure, and my dq dot front will be storing the index of the maximum value of the current sliding window. So what I will do is, if in case my I is greater than equals to k I minus k, I will simply push back answer dot push back nums of dq dot front. uh, so what this was doing, try to think what this was doing. This was actually popping out elements from front, popping elements for out of range. And what this is doing, popping small elements, and what this is doing, pushing the current element in the queue. And what this is doing, this is storing the final answer. This is storing the final answer. So this is the whole gist of the code, and all the bases, all the base cases, all the side edge corner cases are handled in this code. Now I hope you would have understood the problem very well. Now let's move on to the coding section. Yeah, so I will here I have made the data structure dq, and I will be starting from I equals to 0. So we will be popping out the element from the front till the time the front element is out of bound of the current sliding window, and after doing that we will be popping out element from the back, since all of those elements will be pop out from the dq, which are actually smaller than the current element because we do not need them and they have less scope in the future sliding windows. So we'll pop back the elements from the back of the queue. Now I'll push back the current index in the dq, and in case my index I is greater than equals to k minus 1, I will simply push back nums of dq dot front, and in the final I will be returning the answer. So yeah, that's all for the code, and this is an accepted code. Let's submit and see it. Yes, so it has been accepted, although this question was done by me a few minutes back also, and this is an accepted code, I guess so. Yeah, so internet issue, but this is an accepted code. And please hit the like button as well as subscribe my channel, and do hit the bell icon for more such videos. In case I update any or in case I upload any video, you will get the notification of it. So please hit the bell icon, hit the subscribe button, and hit the like button, and please promote me. If you like my channel, if you like my explanations, please help me grow. Also, if in case you find anything that is not I'm not up to the mark in anything, please let me know in the comment section. I'll surely try to improve it.
thank you, and thank you very much for watching these videos. Thank you.